Assalamualaikum and good morning to fellow panel 1, Dr. Khairul Anwar bin Ibrahim, and panel 2, TS Asri bin Din. In this video, I'm FAZLI bin USIN from 4 BEEI FTKEE student would like to present about my bachelor degree project entitled Energy Storage System of Regenerative Braking in Urban Railway based on Supercapacitor. Project description: Energy storage system of regenerative braking in urban railway based on supercapacitor is a project that focuses on using supercapacitor as energy storage system in order to store and recycle waste energy by regenerative braking in urban electrification railway. Besides decreasing energy consumption, utilizing regenerative power is one of the most effective way to save energy. For the introduction, rail transportation is arguably one of the most efficient methods for mass transportation of passengers. This makes it popular choice for satisfying increasing transport demand in an environmental concerned economy. Besides, with the growing renewable sustained energy, the demand of electrical transportation system is increasing. Because of this system prevent environmental pollution, also reduction of energy consumption. Then, when the train stop, it produce high voltage motor. Also, high amount of braking energy is produced. When a train is operated in powering mode, it will consume power from well-set power substation or onboard power supply. In urban railway operation, energy saving operation can be achieved by reducing energy consumption and increasing regenerative energy usage. Supercapacitor is an energy storage technology that rapidly developing and being implemented in various industrial applications. Some electrical rail transportation systems use supercapacitor for voltage enhancement and recuperation of regenerative braking energy. So why I'm using supercapacitor? This energy is not new and already being used by many developed countries like Europe, Germany, China, Japan because of the unlimited cycle life, energy specific power, low resistance, enable high load current, charge in second, save long lifetime, can reach 20 years, less maintenance, and many more. Only in Malaysia, we still not using it as energy storage system. Next, for the problem statement, the project want to tackle energy waste that produced by regenerative braking in electrification train. During regenerative train braking, the kinetic energy of train is converted to electricity that can be used or transferred to another system when needed. This is compared to other conventional brake, which is the kinetic energy converted to heat and waste to the environment. Traction power supply substation cannot absorb energy in reverse direction. The excess energy generated during regenerative braking cannot be reused, resulting in energy wasted. Alright, next for the objective. First, to develop the effective energy management for reduction of energy waste and consumption on urban railway. Second, to investigate and study the behavior and characteristic of supercapacitor. And third, to design the simulation modeling of energy storage system using supercapacitor. For the methodology of this project, based on the first flowchart, this project started with the analysis of actual energy consumption. So since this project based on Malaysia electrification trend, The first electrification railway service in Malaysia is KTM commuter. The KTM ETS, also known Kereta Api Melayu electric train service, using electric multiple unit EMU train. The KTM ETS is the second electric train service to be operated by the Malaysia Railway Company. So one of the train that using regenerative braking system in Malaysia is the KTM model, the KTM class 93 model that started operate on 3rd September 2015. Then for the railway power supply system, the class 93 train use traction power distribution system and powered by electricity from catenary overhead line. An overhead line consists of one or more wire or rail particular internals situated over rail track raised to high electric potential by connection to feeder station at regular interval. The feeder station are usually fed from high voltage electric grid. And next, the recuperation of regenerative braking. This class 93 model use regenerative braking system as its braking system. The conversion of kinetic energy to electricity, commonly known as dynamic braking, is based on the capacity of electric motor to also act as generator. In contrast to friction braking, it does not generate wear, tear, dust, smell or sound, but with current technology, regenerative braking appear to be a very promising solution to reduce energy consumption in electric urban transport network. So from this regenerative braking, why I'm using what system that I want to use to prevent the waste of braking energy. So I will use onboard energy storage system. The outstanding advance in both power, electronic and energy storage technology have enabled it to become an excellent option for reuse regenerative braking energy in urban rail. So where I want to store the wasted energy, so the best way to deal with regenerative braking is to store energy in supercapacitor, the electrochemical double layer ECDL capacitor. The reason I'm choosing supercapacitor is because of long time, low size and weight, easy to control, easy to calculate, state of charge of element and others. First, the concept of energy storage is emerging as solution to energy management, energy saving and perform improvement for power system. For the circuit modeling, in order to achieve better energy saving effect of the supercapacitor energy storage system, an online optimization control strategy is proposed in the modeling scope. So the modeling of the system is essential to simulate the real system on computer using computer software. I'm using MATLAB software. MATLAB provide a user-friendly interfacing that allow the user to model and edit project easily. So this is my full circuit diagram and this is my flowchart of this circuit. And for the flowchart, the PMW will generate signal. When the signal is received, battery and supercapacitor is charged by power supply until certain limit, maximum 100% and the minimum value is at least 90%. Then lastly, it will plot graph of current, demand, voltage. The SOC, the state of charge, will be measured and graph and perform accordingly. So for the circuit simulation, I will do the comparison with other storage system, that is battery, to prove that supercapacitor have more advantages, and I will explain more detail on my demonstration video later. So the for the result and analysis from the circuit simulation, I will display the current, voltage, and the SOC state of charge, and also the power output for both energy storage, supercapacitor, and battery. And I will explain more detail on my demonstration video later. So the conclusion, the rapid advancement in the power electronic technology today has allowed us to explore the benefit of supercapacitor as an energy storage element that provide advantage in many ways apart from batteries, such as the battery storage deterioration. For the simulation result, MATLAB Simulink performed the ideal result for the charging and discharging rate of current, voltage, and SOC which occurred in the charging and discharging process. And for the recommendation, the study of regenerative braking system is an important part of the energy efficient of an electrification trend. So energy saving in this system would promote to the cost reducing, and regenerative braking will seen as alternative to reduce cost consumption on trend as well as reduce the pollution. So to other student or any people who want to continue or want to study more on energy storage technology, I recommend to do more research on such as flywheel, energy electric double layer capacitor, battery, fuel cell, and superconducting magnetic energy storage device. All these technology have been proposed and utilized in railway system for different purpose. So that's all for my poster presentation. Next, I will show my demonstration video.
This is my overall design of circuit simulation. Although it looks easy and simple, but if we convert it into hardware, we already get complete energy storage system. The energy storage was simulated on the basic of the parameter of energy storage itself, battery, here battery and supercapacitor. So for the battery, I'm using lithium ion 30 volt type, and for the supercapacitor, I'm using 16 volt 500 farad model. Then supercapacitor and battery is charged by 42 volt DC supply, which are connected to buck boost converter and boost converter respectively. The resultant output of simulation is analyzed for 600 seconds to obtain the SOC voltage current output of the battery and supercapacitor. The power supply gives power to charge the battery. During the discharge condition, the battery may discharge through a supercapacitor, so the current demand will be smoother. Furthermore, this simulation is comparing between charge and discharge condition of supercapacitor along with battery performance. The switch is triggered by pulse within modulation. To switch on the supercapacitor, switch on the both circuit. When boost converter is on, the supercapacitor is on charging state. So now before we run the simulation, we need to set it normal, and we run it and wait until it finish compile. Now we already finished compile. So to display the result, here we need to press the scope 1, scope 2, and scope 3. Now this is the result. For the scope 1 here battery, and the scope 2 is supercapacitor. So for the scope 1 battery, show that the battery, when there is current charge up, the battery will charging until 100% and slightly decrease once there is no more current supply for charging situation. The battery provides nearly constant voltage, and current is discharged only nearly about 40% during this performance. So for panel information, the SOC for the charging and the current for the discharging result. So for the supercapacitor, it charging nearly 95% and slightly decrease once there is no more current supply for the charging situation. And for the discharging, it discharges 100% completely compared to battery only 40%. And it voltage drop, but at the initial time it provides very high current. The supercapacitor start to discharge over time until it reach zero. Okay, for the power output, show that the supercapacitor provide peak power for short duration and decrease to zero, but battery provide constant power for longer time. The power output of supercapacitor is very high compared to battery. So if we look to the SOC, the battery SOC decrease slowly at the relative stable level, while the supercapacitor SOC change dramatically. So from there we know that supercapacitor store and discharge faster than battery. Since the current of supercapacitor drop with the weekday operation voltage, but battery provide constant current, and increase in the size of the supercapacitor module lead to an improvement of the power system efficiency. So the simulation revealed the difference of battery and the supercapacitor in nature. Supercapacitor is good to provide high peak power, but its energy density is lower. For battery, has higher energy density, but its power density is lower. So lastly, based on the simulation result, comparing the supercapacitor with a battery has its own merit. So the capacitor is non-electrochemical, and the maximum voltage is determined by the type of the electric material used as separator between the plate. The presence of electrolyte in some capacitor boosts the capacitance, and this may cause confusion. Since the supercapacitor is non-chemical, the voltage is free to rise until the electric fails. This is often in the form of a short circuit, avoid going higher than the specific voltage. So that's all for my presentation. Thank you.